Okay, so our next topic in Unit 2 is having to deal with parallel and perpendicular lines. Okay, so parallel and perpendicular lines is going to be your next Newton assignment. It is also, there's also a worksheet for parallel and perpendicular lines. Okay, so once you finish this video, you'll be able to do both the Newton assignment and the worksheet having to do with parallel and perpendicular lines. Okay. All right, now mine didn't copy very well. I ran out of ink, so I had to kind of go over my lines. Hopefully yours look a little bit better than mine do. But parallel lines look like this, right? People talk about them being the goal on the football or something like that, or the football goal, right? Those are parallel lines. Parallel lines are unique in that they never touch or they never cross, and that's because they're increasing or decreasing at the same rate of change, meaning rate of change. That's their slopes. Their slopes are the same, okay? So if one slope is m, then the parallel slope is also m, okay? And the way we shorthand that is we do two parallel lines next to our m to let us know it's going to be the same because that's a parallel slope, okay? Then for perpendicular lines, they are unique in that they cross at exactly a 90-degree angle. So notice here the x and the y-axis are perpendicular lines, right? Because they cross at a 90-degree angle. Or you could have any lines crossing out in the plane, right? As long as they cross at a 90-degree angle, then they're perpendicular lines, okay? And they have special slopes as well. Slopes of perpendicular lines are opposite reciprocals, okay? Opposite means we're changing the sign, okay? Plus, minus. And reciprocal means that we flip it, okay? So opposite, if the slope was originally positive, then the opposite would be negative, right? Reciprocal means we flip the fraction. So if we had 1/2, we now have 2/1, okay? So we change the sign and we flip it. And the way that we denote perpendicular slopes is with the little 90-degree angle. So we put the little 90-degree angle and then our slope. That way we know it's opposite reciprocals. Parallel is the same, perpendicular is opposite reciprocals. Okay, so that's the first thing we're going to go over is just looking at, okay, well, if I am given two lines, how can I tell if they are parallel, perpendicular, or neither, right? Those are our three choices. They either have the same slope, they have opposite reciprocal slopes, or they have slopes that are just not related at all, right? So let's go ahead and look at these. So when I look at these first two lines, notice in order to see their slope, I really want it written in y equals mx plus b format, right? I really want it written like this because then I can easily see what the slope of the line is. So if I look at this first equation, right, I'm going to go ahead and move it over here. If I write y equals 6x minus 3, notice it's already written in that form. So I can easily see here that my slope is 6, right? So now I want to do the same thing for the second equation, but it's not solved for y. So I can't easily see what the slope is. So that's what I'm going to do. I'm going to take this line, solve it for y, so that I can see the slope. So if I want to solve this for y, the first thing I'm going to do is add my 12x over to the other side. So that gives me 2y is equal to, now since I want it written in y equals mx plus b, I want to make sure my x term comes next, right? 12x minus 1. And then to get y completely by itself, then I just divide off the 2. I'm going to go ahead and just divide it off each term. So I end up with y is equal to 6x minus 1/2. And now that it's solved for y, we can easily see that our slope here is 6. Right? So notice my slope here is 6 and my slope here is 6. So because these two are the same, right, then that means that these two lines are parallel because parallel lines have the same slope. Parallel. Okay, make sense? So solve each line for y and then just compare the slopes. If they're the same, then they're parallel. If they're opposite reciprocals, then they're perpendicular. And if they're not related at all, then they're neither, right? All right, let's look at another one. Same idea. I want to take the first line, so 5x minus y equals -7, and solve it for y. So I'm going to move my 5x to the other side by subtracting, which leaves me with negative y is equal to, we want to write our x term first, minus 5x minus 7. And then to get y by itself, I need it to be positive. So to get rid of that negative, I'm just going to divide it by a negative 1. But if I divide that side by negative 1, I have to divide the other side by negative 1, right? Every term of the other side. So I end up with y is equal to positive 5x plus 7. So I can see here that my slope is going to be 5. Now I need to do the same thing with the other line. So if I look at this other line, it's not solved for y either. So to get it solved for y, I need to move my x term to the other side. So I'm going to subtract x from both sides. So I have 6y is equal to negative x plus 1. And then to get y by itself, I then just divide off the 6. If I divide it off on the left, I have to divide it off on the right. So I end up with y is equal to, now when it's written like this, the implied number in front of this x is a 1, right? I really have a negative 1 here. So I'm going to write it with the number first and then the x. So this is the same as negative 1/6 x plus 1/6, right? So here I can see that my slope is negative 1/6. So I have a negative 1/6 slope, and I have an m equals 5 slope, and those are just not related at all, right? They're not the same, and they're not opposite reciprocals of one another. So that means these lines are neither parallel nor perpendicular, okay? Make sense? All right, so there is one for y'all to practice on the top of the next page. So same thing, solve both lines for y, and then determine by comparing their slopes whether they're parallel, perpendicular, or neither, okay? And I am going to let you pause the video, and whenever you're ready to see the answer worked out, go ahead and play it. All right, so when we take our first line here and solve it for y, all we have to do is move that 2x to the other side, right, which makes it a negative 2x. And since we have no coefficient on the y, that gets us into our slope-intercept form. So we can see that our slope here is negative 2. Okay, and the reason I wrote negative 2 over 1 is just in case I need to see if slopes are the same or if they're opposite reciprocals. Okay, if you stopped here at negative 2, that's totally fine. Then I want to look at my second line. To solve it for y, I need to move my x to the other side. Notice it's a positive x, so I subtract it to the other side. And then to get y by itself, I divide off the negative 2. So I divide it off of every single term, and that leaves me with y is equal to positive 1/2 x plus 1/2. So now that I have it solved for y, I can easily see that my slope is 1/2. So when I look at 1/2 and I look at negative 2, right, if I were to take 1/2 and flip it upside down, I would get 2 over 1. And then change the sign, I would get negative 2, right? So that means these are opposite reciprocals, okay? If it's the same number, only flipped upside down and changed the signs, then they're opposite reciprocals. And when we have opposite reciprocal slopes, that means that our lines are perpendicular, okay? All right, so now we kind of understand what parallel and perpendicular lines are. Now we want to use that to be able to find the equation of a line based on this idea that it's either parallel or perpendicular to another line, okay? So here's our strategy, okay? First, we want to find the slope of the line that they give us because they're going to give us some line. And so we need to know what the slope of that line is, okay? Then we're going to determine the slope of your line, okay, or the line that we're trying to find. So we're going to determine based on the line they gave us if it's parallel or perpendicular, whether we're going to use the same slope or whether we're going to use the opposite reciprocal slope, okay? Then we use our slope, okay, the one that we just determined, not necessarily the one from the line given, because it could be different, right? But the slope we have determined and a point, the point will be given to us, and we're going to use this point slope formula to find the equation of a line. Remember the point slope formula from the last section is y minus y1 is equal to m times x minus x1. Okay, so we're going to determine our slope based off of the line that they provide us. Then once we have our slope, we take that slope and a point that they gave us and just plug it in here. Okay, and then we want to write our equation in slope-intercept form. So once we plug it in, we're solving for y so that our answer turns out looking like y equals mx plus b. All right, so let's look at some examples. So on this first one, it says find the equation of a line that is parallel. Okay, parallel means same slope. Okay, so it's parallel to this line and it goes through this given point. So I'm just going to ignore this point for just a second, and I want to focus on this line that they gave us. Okay, they gave us 6x plus y equals 8, and I want to know what is the slope of that line. So I need to solve it for y. So I'm going to go ahead and subtract my 6x to the other side, which gives me y is equal to negative 6x plus 8. And now I can easily see here that my slope is negative 6. Okay. So negative 6 is the slope of the line they gave me. And we want to find the equation of a line that is parallel to that line. So if our line is parallel to this line, that means we want the same slope. Okay, so our parallel slope is going to be negative 6. Okay, so we're going to use the slope that we just determined for our line and the point that they provided us, and we're going to plug it into our point slope formula, which is y minus y1 is equal to m times x minus x1. Okay, and this point they gave us is our x1, y1. Okay, so we have y minus the y from the point that they gave us, which is negative 3, is equal to our slope that we determined to be negative 6 times x minus the x from the point that they gave us, which is 7. Okay, and then from here, we're just simplifying. So double negatives become positive. So I get y plus 3 is equal to, I'm going to distribute my negative 6. So negative 6x plus 42. And then I just need to move my 3 over to get it completely solved for y. So I subtract 3, which gives me y is equal to negative 6x plus 39. So this is the equation of the line that goes through this point and is parallel to this line. Okay? So notice when we're finding the equation of a line, we're still going through the same process of using this point slope formula. The only difference here is we're getting our slope based off of a relationship to another line. Okay? So let's look at another one, and then I will let y'all try some. So on the top of the next page, it says, find the equation of a line that is perpendicular to this line and goes through the point 2, negative 9. So when we see perpendicular, okay, that means that we know our slopes are opposite reciprocals. Okay, opposite reciprocal slopes. So before I can determine what the opposite reciprocal slope is, I need to know what the slope of that line is in general. Okay, so I'm going to go ahead and write x plus 2y equals negative 8 up here and solve this for y. So I'm going to move my x to the other side by subtracting. So I have 2y is equal to negative x minus 8. And then I need to get y by itself by just dividing off that 2. So I divide 2 off of everything. So I end up with y is equal to, again, here I want to write the number times x. So what's in front of the x right now is a negative 1. So this is the same as saying negative 1/2 x minus 4. So here I can see that my slope is negative 1/2. Okay. Now, I don't want the same slope, right? Because I want my line to be perpendicular to it. So I want the opposite reciprocal slope. So my perpendicular slope, if I flip this upside down, I'll get negative 2/1. And then I have to change the sign, which will make it positive. Positive 2/1, right? Or in other words, my slope here is just 2. So I take the slope of this line, I flip it, I change the signs, and now I have my perpendicular slope. So I'm going to use that perpendicular slope along with the point that they gave me and plug it into my y minus y1 is equal to m times x minus x1 point slope formula. Okay? All right, so let's go ahead and plug it in. So we have y minus the y value from our point here, which is negative 9. Is now equal to our slope that we found, right? Our perpendicular slope, which is 2, times x minus the x from the point that they gave us, which was 2. And now we just simplify, right? Our double negatives here make this a positive 9. When I distribute my 2, I'm going to get 2x minus 4. And then the last thing I need to do is move that 9 to the other side. So I'm going to subtract 9, which gives me y is equal to 2x minus 13. And I just leave it like that. Okay, so this is the equation of the line that is perpendicular to this line given and goes through the point 2, negative 9. All right, so there are 2 for you to try at the bottom of this page. Go ahead and pause the video and work them out. And when you're ready to see the answers, or if you get stuck, go ahead and play the video and you can check yourself. Okay. All right, so let's go ahead and go over them. So on number 1, when we solve to find the slope of the line given, we get negative 2. We want our line to be parallel, which means we want the same slope. So our parallel slope is going to be negative 2. So we're now going to use that slope negative 2 and that point that was given to us, and we're going to plug those into our point slope formula. Once we plug in negative 2 for our y1 and negative 7 for our x1 and solve for y, we should get negative 2x minus 16. Okay, if you need a little bit more time, go ahead and pause the video. If not, let's go ahead and go over number 2. Number 2, this time we want a perpendicular line. So when we find the slope of the line given, which should be negative 1/4, we don't want to take negative 1/4 as our slope because our slope is opposite reciprocal because our line is perpendicular. So if I do the opposite reciprocal of negative 1/4, that gives me a positive 4. Okay, so I'm going to use that slope, positive 4, along with the point that they gave me and plug it into my point slope formula. So negative 3 goes in for my y1, 7 goes in for my x1, 4 goes in for my slope, and then I'm just solving for y. Okay, I should end up with y equals 4x minus 31 is my answer. So if you need more time on that, you can always go back and watch more of the video or pause it or do whatever you need to do, okay? But now that you have the information on parallel and perpendicular lines, you have 2 assignments now that you're able to complete: the Knewton assignment, parallel and perpendicular lines, and also the worksheet over parallel and perpendicular lines, okay? Let me know if you have any questions.